Hello, how was your lunch? How was the chicken? I don't see Mike DeWine, so they must have actually freed the chicken. So he's probably out celebrating right now. We're going to do a tag team. I'm going to give you an outline and cover a few things, and then Mark will get up, and Eric, and I'll come back. And anyway, we're going to cover the IECC residential, give an overview of that, discuss the DOE determination on the 09 IECC, overview of 90.107, determination. Actually, a question a number of folks have asked, if you looked at that legislation or the summary of the legislation yesterday, kind of says adopt 90.107 or equivalent, so there's a lot of questions about whether Chapter 5 of the IECC is equivalent to 90.107. We're going to have a focus on lighting, progress toward the 30%. Rose is going to come up and cover education and training, and Linda's going to cover compliance software. So our scope really, and what we're covering, is development of energy codes and standards, and then educational and support materials or an infrastructure to foster compliance, implementation, and application of those documents. The purpose of this is activity to provide a high-level view in this presentation of current status of energy codes and standards at the national level, and some initiatives that DOE is fostering through the Building Energy Codes program. And then the expected outcome for you in the audience is really the ability for you in your jobs and responsibilities to more effectively plan for and implement things as these changes are occurring. So in terms of the IECC, the 09 applies to new buildings and additions. This is a high-level view, overview, renovations, alterations, and repairs to existing buildings. Above code programs are okay, and alternate materials are okay when approved by the code official. So if you've got something you want to do that's not specifically covered in the code, you can get building regulatory approval for that alternative. And also if you have in your state, for instance, an alternate program, maybe a HERS or something of that nature, you can get a code official to validate that in fact is equivalent, so you can follow that program instead of the code. And then the code identifies the climate zone where the building is to be located. There are 8 climate zones in the U.S. You have to design and construct the thermal envelope with respect to insulation. There are a couple of paths to compliance: prescriptive, R38, R19, R13, what have you. U factors by assembly, the wall, opaque wall U value of X, or an overall UA for all opaque walls. Put a little bit more in the ceiling and a little less in the walls, and you can show compliance. There are provisions for fenestration, thermal properties, and air leakage. I know if you've traced these over the years, you would see that what they used to call U values, now U factors, those numbers have come down significantly. If I remember the original ASHRAE 9075 that was published in August of 1975, the U value requirement for an area about 4,000 heating degree days, as I recall, was about 0.9 or 1 or something like that. And now it's not unusual to be talking about U factors for window assemblies of 0.3 or 0.35, etc. Air leakage, you have a visual inspection or a blower door test. And the provisions vary by climate zone. Again, historically, if you remember the original ASHRAE standard, it had a graph of U values for assemblies by heating degree day. And over time, what's occurred is, just in the county where I live, Fairfax County, Virginia, statewide mini-maxi code, heating degree days go from 3,950 to 5,002. It's really hard when the municipality is a county that's fairly large. It's really hard to say, well, on this side of the street, we're going to do this number, and on that side of the street, we're going to do another. So over time, you've seen that things have gravitated towards less specificity, per se, and gone into climate zones to make it a lot easier. So in Virginia, we have one zone. We're in Zone 4. It's real easy throughout the state to deal with. HVAC system controls, there's a limit on oversizing of HVAC equipment in relation to calculated loads. Insulate the duct system, test the ducts, insulate HVAC system piping, and 50% or more of the permanent lighting fixtures have to be high efficacy lamps. And that there's a high efficacy is defined in the code as a certain number of lumens per watt based on the wattage of the fixture. So that's kind of an overview of the 09 IECC, and I'm going to turn it over to Mark for a moment to cover the status of DOE's determination of the 09 in relation to does it save energy over the 06, et cetera.
Gene talked about this, I believe, the other day. DOE is required to do a formal determination of the energy savings of the IECC. The legislation actually refers to the Model Energy Code. DOE expects that their determination of the 2009 IECC will be published in April 2010. And based on the calculations that DOE has already made public, we expect that the savings in that determination is going to be about 15%. What that means, once DOE issues their determination, is that states aren't really required to provide any certifications. However, the DOE does recommend that states focus on the 2009 IECC. Number of states are probably looking at the 2006 IECC. That is a step backwards for some states in the United States. And the federal legislation that we've been talking about, the Recovery Act, also directly points the states at the 2009 IECC. And I think we're going to turn it back. I've got the next couple of slides too. So we switch from residential to commercial. 2007. 90.1 2007 is basically an incremental improvement over 90.1 2004. The big target is 90.1 2010. That's where the 30% savings is supposed to occur. You're not getting 30% in 90.1 2007. 90.1 2007 looks an awful lot like 90.1 2004. It's got requirements for envelope, mechanical systems, both HVAC and surface water heating, and for lighting and power systems. There were 44 distinct addenda approved to standard 90.1 2004 that are included in 90.1 2007. 10 different changes in the envelope area, 13 in mechanical, 8 in lighting, and 13 other changes to the standard. Of those 44 changes, some of them save energy and some of them don't. We look at them, we estimate that about 30%, 3 of the envelope addenda actually will result in energy savings based on the way that we capture those energy savings. Most of the mechanical addenda are going to achieve some energy savings. Most of the lighting addenda in this 90.1 2007 aren't a big deal, and none of the other addenda are as well. So let me talk about the ones that we think are going to have some big impact. The 90.1 2007 has modified vestibule requirements. More buildings are going to be required to put vestibules in place. There's also some changes to the opaque envelope requirements and changes to the fenestration. Both of those have gotten more stringent as a general rule. Not for every building, not for every location, but as a general rule. On the mechanical side, we've got a whole bunch of changes. Some of the changes that are in standard 90.1 2007 are merely changes that are updating the requirements that are printed in the standard to minimum federal manufacturing standards. There's a change in the standard, but it's really not going to impact too many people because you can't buy equipment that's worse than those numbers anyway. So that's the three-phase air-cooled air conditioner and heat pump efficiency requirements and the air-cooled air conditioner and heat pump efficiency requirements. Both of those were changed in the standard. Both of those were changed to meet federal manufacturing requirements. There has been a number of changes to how data centers are treated in standard 90.1. They used to have a couple of exceptions, special exceptions just for data centers. Some of those exceptions have been removed. ASHRAE got a lot of evidence that the data centers didn't need quite the tight control of the temperature that everybody has always thought that they do need, and so they removed the exceptions. That's going to save energy. They've changed some of the requirements for hotel motel guest rooms, meaning there'll be a little more control of those systems. And they've changed the ventilation requirements in standard 90.1. We talked a little about this morning. Standard 90.1 refers to standard 62 for ventilation. Standard 62.1-2004 is the new version of standard 62. It does require a little less air in some building types. That has a big impact on the energy usage of those buildings. Moving on to some of the other changes that are going to show up in 90.1-2007, there's a new combustion efficiency requirement for boilers. There are new requirements for demand-controlled ventilation. There's a modification of the existing fan power limitation. That's the requirement that tells you how much power you're allowed to use for your fan system, depending on how big the system is. There's modification of the boiler efficiency requirements, modification of unit heater efficiency requirements, and some changes in the part load fan power requirements as well. So based on all these changes that DOE has been looking at, again, we're required to come up with a determination of energy savings. We started out our process in this area with a meeting in February 2009, and we hope to have the 2007 determination published in January 2010. We expect the savings are going to be on the order of about 5% over standard 90.1-2004. Not a lot, but not insignificant either. So it's a good standard. In terms of certifications on commercial, once DOE issues that positive determination, DOE expects that states will have adopted a commercial energy code that meets or exceeds standard 90.1. That should have said, this is the certifications that are due for the previously published determination, standard 90.1-2004. States are required by January 2011 to certify that they have adopted a code that meets or exceeds 90.1-2004. And DOE says, sure, you can send in those certifications, but you might want to think about 2007, because it's also going to have a positive determination, and that's the one that's also called out in the Recovery Act. So that's the directions to the states from DOE. We'll now talk about the topic that Dave mentioned, which is the comparison of Chapter 5 of the 2009 IECC and Standard 90.1. So Dave will take over.
Okay. What if a state adopts the 09 IECC for commercial? Would it be considered in compliance with ARRA SEP guidance to adopt 90.107 or equivalent? And a little bit of history on what's now Chapter 5 of the IECC, which is commercial buildings. There didn't used to be a Chapter 5, and prior to it being the IECC, it was the CABO Model Energy Code, and it didn't have a Chapter 8. When 90A and 90B were updated in the 80s, the result was published as 90.1-1989. And in parallel to that, in the 80s, in parallel to that, there was a CABO Model Energy Code, yellow cover, that maintained consistency and was updated, etc. And for commercial buildings, when 90.1-89 was published, there was a focus on adopting that for commercial buildings. A number of folks felt that it was too complicated, especially for small commercial buildings. Many instances for a small commercial building, the builder or contractor or designer said, tell me what you want. It's really no different than a house. In fact, in, again, Fairfax County, Virginia, we've got some houses that are design build that are over 15,000 square feet. You know, but hey, in any event, well, they haven't been building many of those lately, but they were built during the dot-com boom. But the point was, folks said, gee, I don't want to read an equation that's 3 pages long. You know, I got a small commercial building. So a Chapter 8, which is now Chapter 5, was developed, and it was first put in the Model Energy Code in 1995. And it was a simpler prescriptive set of provisions. That's a little bit of background. Well, that's been maintained. You've had 90.1, 89, 99, 01, 04, 07, 10 updated and maintained for commercial buildings. At the same time, you've had 95 MEC, 98 MEC, 00 IECC, 03, 06, 09. So the question is, does Chapter 5 of the IECC, which covers commercial buildings and for certain commercial buildings adopts 90.107, is that equivalent? So the approach to answering that question was a careful review of the requirements side by side to determine differences and the issue of equivalency. And these are some of the findings. And I'll make a point that it's possible on a building type basis, take a particular building of a particular area and use group, etc. It's possible to take building 1 and put it in some place in the country and find some minute detail where you'd say, well, if it designed it to 90.1, it would be a little bit better than the IECC. And you take that same building and put it in a different area of the country, climatically or geographically, and you'd have a completely different conclusion. And then you could take a different building with a different design, and you could do the same thing and get, in one area of the country, 90.1's maybe a little bit more, and in the other part of the country, same building. The point I'm making is because the documents are not identical, you have there are cases where one might be, for a particular building, a hair more stringent than the other. And so we're trying to look at this in an aggregate when we compare these. So 90.107 has a designation for semi-heated spaces. And if I am defined as a semi-heated, then I have a different set of thermal envelope provisions. Well, the IECC doesn't have that. And in fact, under the IECC, because there's no distinction, what would be called semi-heated in 90.1 with a less stringent envelope provision in the IECC is really a heated space. So that's a case where, I don't know, we don't want to keep score here. Ron's gone, so we can't pick on the SEC. Okay, and I see Mike there. Mike, did you find the chicken? Was it freed or did it? Okay, cool. So this is a case where you definitely look at this and say, you know, that's a case where IECC has a slight leg up. The provisions in both documents for heated spaces are generally identical, but when you get into it and you look at the numbers and climate zone, and maybe one's tweaked a little bit different than the others. Keep in mind when you look at those two processes this morning, all interested and affected parties can submit changes. So you've got people's industry and others submitting changes to 90.1. In parallel, you've got them submitting to the MEC, or excuse me, the IECC. And that's no different than years ago when the 3 legacy organizations, BOCA, ICBO, and Southern, that Dave Carmel mentioned this morning, had the building code, the fire code, or whatever. Industry or anybody had 3 shots. You could go down the south and try and get sprinklers in, or you go to the west or whatever. You have different documents and different processes. There will always be, because of the involvement in folks and the fact that different people are making different decisions, you're always going to have the probability of 2 documents under 2 different processes, you might have differences. But the provisions in both documents for skylights and vertical fenestration are also generally identical when you look at the fenestration provisions. The climate zones are the same in both documents. That's nice. It's nice to know that ASHRAE and ICC agree on how many heating degree days we should have in Fairfax County. But what's real interesting when you get into the glazing is the IECC says if your glazing is from 15 to 30 degrees of horizontal, it's part of the wall and it's subject to the fenestration provisions, but 90.1 considers that same glass a skylight, and it's applicable to, and you have skylight provisions. It's when you look at the definitions of skylight in IECC, we've got kind of a hiatus or a gray area where one says, no, that's a skylight, and the other one says, no, that's fenestration. And when I go to the tables and I look at U factors for skylights versus U factors for fenestration, they're different numbers. So some glazing under, we'll say the ASHRAE standard, would be considered skylights rather than vertical, etc. And so you have that kind of a technical difference. And then a building evaluated to the 09 IECC will reach, because of that, what's called a 40% wind-to-wall ratio limit faster than one under 90.1. If you're familiar with this, you do the IECC, if you're over 40% wind-to-wall ratio, it says you've got to go to 90.1. There's no alternative there. Well, I'm actually then in the IECC, because of this subtlety, if I have skylights in the buildings, I'm actually sent to 90.1 by reference sooner. And when I get to 90.1, it has a provision about if you're under 40%, you can do this alternative. So if I'm like at 40.5% under the IECC, you see what I'm doing? I'm sent to another one. When I go to the other one, the metric, the way it's calculated, I'm at 39.5. Okay? And what's interesting about this is everybody, in my experience, not everybody, but it's not unusual for people, what are the requirements? And they jump into, you know, the technical provisions, and nobody reads the definitions. And in many instances, the definitions and how I define something can be just as important. So I just covered this kind of 39, 41%, et cetera. So 90.1 and the IECC vary as to which is more stringent with respect to envelope provisions. When I take the fenestration, when I take the walls, et cetera, there are slight differences in the numbers. And the two documents treat above and below grade walls differently. The latter, IECC, being a little bit less onerous. Under the ASHRAE standard, what's above grade is treated as above grade, and what's below grade is treated as below grade. Draw the line. Anything below the dirt is below grade, and it meets one set of provisions. If it's above the dirt, it meets another. But in the IECC, I look at this 15%, 85% ratio. That is, if more than the wall is above 15%, then I treat it as above grade, and if the more of it is below, it's like 86% is below grade, I treat the whole wall as below grade. Subtle difference. Depending upon the actual building configuration then, with respect to basement first story, one document or the other could be considered more or less stringent than the other. In this instance, it's about where do I pile the dirt? And where am I with respect to this 85, 15, et cetera. 90.1 has provisions for high albedo roofs, reflectivity and emissivity. In certain climatic zones, the IECC does not. I believe there's a provision to put those types of provisions in the, or at least proposed to go in the 2012 IECC, but right now I don't. I'll call it cool roofs, if you will, in certain climates. It's more probable that a building meeting the overall envelope approach under the IECC, this is this UA, would have a lower heating and cooling load associated with the building envelope, not including infiltration, than if the same building were to just meet 90.1. It's more probable. Like I said, you get into climate zones, you get into this 15%, 85%, all of these different factors I mentioned, skylight versus vertical, this table of fenestration requirements in ASHRAE versus this table in IECC. When you take all of that into the mix, again, as I said, I can find a building of a particular type and design and put it in one area of the country or another and show that one, okay, but in the aggregate, it's more probable that a building built to the Chapter 5 of the IECC would meet or exceed the same design, designed to 90.1, heating and cooling loads. There are different thermal requirements for residential and non-residential. It's more likely that some buildings or portions of buildings would be considered residential under 90.1 and then commercial under the IECC, yielding a situation where in some instances a building built to the latter could have greater heat loss or gain through the thermal envelope than if built to the former. I know I'm kind of tying up terms here, but when you get into, it's always bothered me at least that we have these terms residential and commercial. Now they're defined in the code, but if I look at folks that are coming from the code community and I say residential, well, what goes through your head is R1, R2, R3, R4. Yeah, I got dormitories, I've got, you know, hotel, motel, I've got all of those types of things, sorority houses, fraternity houses, etc. And it's not that simple. Residential in terms of the IECC is a little bit different than 90.1. It's more likely that some buildings or portions of building would be then considered residential under 90.1 and so on and so forth. And then you end up, because you've got provisions for the envelope, if it's residential, do this. Oh, it's commercial, do that. See what I'm saying? You end up applying different provisions. IECC limits HVAC equipment oversighting, 90.1 doesn't. They both say to calculate loads, but 90.1 doesn't tell you what to do once you've calculated the loads. Calculate the loads, fine. But IECC says not only calculate the loads, but we want the equipment sized to those loads. 90.1 requires the delivery of an O&M manual for the building systems. You get a car, you get a owner's manual in the glove box. 90.1 does not. And there are a number of subtle differences. I mean, I don't want to go into minute detail, but when you get into HVAC equipment, systems, controls, individually they don't look like much because it's kind of slightly different wording. But in the aggregate, 90.1 tends to be a little bit more rigorous in some cases. Fume hoods, cooling towers, dehumidification, kitchen exhaust systems where I'm doing energy recovery. And it has requirements that aren't in the IECC. Harry, what are you doing with my briefcase? Well, I'm just worried it's getting too close to the door. I like to pick on Harry, that's okay. But you have to understand, as I think was covered this morning, ASHRAE standard is a standard. It's a design standard. You're going to do the energy thing, you pick up the standard. The IECC has an energy focus, but it's one of 14 codes. And it's intended to be used as part of a package, a building regulatory package. So you have, I might not find something on fume hoods or lab hoods or kitchen exhaust in the IECC, but I'd probably find it in Chapter 5 of the International Mechanical Code. I might not find something in the service water heating provisions of Section 504 of the IECC, but I might find it in the International Plumbing Code. So it's, when someone says, well, 90.1 or equivalent, it's not just a case of the IECC, but you may also have to go in certain instances down into other provisions of the I codes. Lighting power limits are the same in both documents, but there are subtle differences in the two documents with respect to exceptions and lighting controls. But the watts per square foot are the same. But again, when you start looking at controls, unless the same section numbers and they're really the same exact wording, it really becomes somewhat difficult to find them, match them up, and compare them. There's some subtle differences, but not significant. And some provisions, such as voltage drop limitations in 90.1, are not in the ICC, but the I codes adopt by reference NFPA 70, the National Electric Code, and when you get into the National Electric Code, you'll find there are provisions in there for circuits, feeders, branches, et cetera, et cetera. So I'm going to turn it, the summary, and then I'm going to turn it back over to Mark, is there are significant positive and negative differences for each. DOE has not attempted to quantify the differences using whole building simulation. I mean, think if you went through just the bullets I just gave you, how many prototypes in how many climate zones would we have to run? And at the end of the day, it's my view, having spent some time on this, that in the aggregate, you're not going to find that much difference. And at this point, the department has not made an overall conclusion based on what we've produced and given to the department to review. So with that, and I guess we'll get to questions at the end of the presentation, I'm going to turn it back over to Mark, who's going to kind of look beyond 2007 to 2010.
As I pointed out before, our real focus is on 90.1 2010, and 2007 is a step towards that. So we're going to talk a little about what's going on right now in ASHRAE and what's going to be in 90.1 2010. I'm going to talk about some of it, and then I'm going to turn it over to Eric to talk about lighting, because that's where some of the most exciting stuff is going on. The big picture. So part of the way to standard 90.1 2010 on the envelope, ASHRAE is already going to be requiring high albedo roofs, cool roofs in some climate zones. There's some new metal building requirements in the standard. There's some new adjustments for projection factor, solar heat gain coefficient, and there's new vestibule requirements. But ASHRAE is also working on a whole bunch of other stuff as well. There's complete overhaul of the building envelope requirements has been going on for the last year and a half or so. There's going to be a lot of new envelope requirements. For the most part, they're going to be a lot more stringent than what you've seen before. There's likely to be continuous air barrier requirements in standard 90.1 2010. And there's likely to be some new skylight requirements in terms of actually requiring skylights in certain situations, not just allowing skylights, but requiring skylights in situations where they can provide daylighting. On the mechanical side, they've already approved some new variable air volume fan requirements for large single zone units. They've gone to the new ventilation rates in standard 62.1. They've got the demand control ventilation. They've got limitations on the amount of fan power. They've got some new requirements for heat pump pool water heaters. But they've also are working on a whole bunch of other things. More VAV fan, oh, that's a duplicate there, excuse me. Heat pump requirements, centrifugal fan cooling tower limitations, pump head calculation requirements, pipe sizing and insulation requirements. There's also some work going on possibly some new chiller efficiency requirements. So there's a lot going on the mechanical side. But over the course of the years, going back to 9075, probably most of the energy savings in codes has come from changes in lighting. Everybody remembers those old buildings that had 8, 9, 10, 11 watts per square foot of lighting in them, and the codes have gradually whittled that down. That's also what everybody sees when they go into the building, is the lighting. So we thought we'd spend a little extra time talking about what's in the lighting, and we've got Eric to talk about that because that's his bailiwick. So come on up.
Okay, like Mark said, I want to give you a little kind of a preview of what's coming for 2010. And as you can see, there are a few things that have already been approved. There is an addenda for lighting credits for automatic lighting controls. Briefly, this is a table of credits that says if you put in a very advanced, which usually means expensive and complicated control, you can get a credit of a little bit of extra LPD you can use somewhere else in the building if you have a special application for it. Automatic lighting shutoff in guest rooms. I don't know if anyone uses the guest room bathroom as a night light, but data suggests that happens a lot, and so there will be a requirement that it be occupancy sensor controlled with a night light provision. 4-zone exterior, you're familiar with in 2004 and 2007 there is an expanded exterior lighting table compared to previous versions which didn't really deal with it much at all. What's going to happen in 2010 is that's going to be expanded to 4 zones. I'll explain that in more detail. Daylighting requirements, as Mark mentioned, there is now a requirement to put in skylights where it's applicable in a building. There are also requirements to control lighting when you have daylighting, and I'll go over those in a little more detail. Additional occupancy-based control. For the last several years, there has been requirements for certain space types to have occupancy sensors as part of the control for lighting. That's going to be increased. There will be more spaces that require that specific control. There are also requirements for low-voltage dry-type transformers that essentially mimic federal regulations. There are a few other items that are in process, and I wanted to mention those and discuss one of them in a little more detail. Interior lighting power density. The last time that was revised was in 2004, and it's been quite a few years. Technology has changed, the design has changed, and so there is going to be an update, and I'll provide some details on that as well. Receptacle load control requirements. This is something that's been talked about for many, many years. Plug loads, if you want to call it that. We are proposing a requirement, fairly straightforward, but we think it's something that will actually go through and can actually be used. I'll describe that as well. And there's electric motor efficiency requirements, again, following federal regulations. So a little more detail on some of these. Occupancy-based control additions, the items in red are the new space types that will be required to have an occupancy sensor control. Occupancy sensors are very inexpensive, generally easy to apply in most spaces, and have probably the best chance of energy savings because they are generally fully automatic. And so we had a first group, the blue ones, before. We're now going to expand that into other spaces. The 4-zone approach I mentioned. The model lighting ordinance and other efforts have been going on for quite a while to define exterior lighting zones. Some zones you just don't need very much light. Some zones you need more. And so there is a document that's floating around that's going to define these for jurisdictions. And what the 90.1 subcommittee did is looked at these definitions, crafted definitions that a building official could probably hang their hat on and actually apply, and then looked at the lighting requirements based on that, because the previous set of exterior requirements was based on any zone, the highest zone possible. Of course, zones that don't need as much light would be wasting it. So just to give you and those are basically their 4 zones. They go from basically dark areas, we don't need any light, all the way up to urban areas where there is a lot of lighting. You need more light to compete, essentially, for contrast. So what happens here, you'll look at, to the far right, the numbers that are essentially in black are what the old requirement was, and that applied to any building anywhere. Now they've been split up into those 4 zones. So the effect is that for the most part, your building will be pushed back into another zone because not every building is going to be in zone 4. So for a lot of applications, the lighting allowance is going to be less. And that makes sense because your lighting requirements are lower. Top lighting, in terms of daylight, there is a requirement that if you have skylights, you must control the lighting underneath it if it's a large enough area. And it's based on a definition of daylight area under skylights. There's also a definition for rooftop monitors. Essentially, if your space is large enough, in this case exceeds 4,000 square feet for most applications, you have to control the general lighting in that space. And it must be controlled in a certain manner. It has to be at least a 2-level output. It can't be just on-off. It has to provide either 2 levels or continuous dimming. So what about the daylight area under skylights? As everyone knows, daylighting can be very complicated. It can be hard to implement. It's got issues, and that's why there hasn't been a requirement until now. We spent a lot of time trying to make this as easy as possible to apply. There are words that go along with this, but this is the easiest way to explain it. The words are there, but essentially what it says is that if your obstruction is tall enough and far enough away, it's going to block light, so you won't get any light here, so that's as far as you have to go. In this other case, if your obstruction is tall enough and close enough, you're still going to get a lot of spillover there, so you will still have to control the light in that area. And in this last case here, the area is only 70% of the ceiling height, and that obstruction is too far away. Those are the basic, straightforward rules of how you define what space has to control lighting. If we look at that in a plan view, again, on the left, you see that the skylight area is blocked by that obstruction. On the right-hand side, it goes over the obstruction, so you do have to control there, and it doesn't quite go here. One other item on this, it shows there's a primary side lighted area. The key here is that you don't have to double control. You're either controlling with the side light or you're controlling with the top light, one of the two. That's the basic requirements. There are some exceptions, of course. I don't want to go into all the gory details, just kind of give you a preview. So what about side lighting? That was top lighting. Yes, for side lighting, if you have windows that meet certain criteria and you have a primary side lighted area, again a definition, then you have to control the overhead lights in that space. And again, similar type of bi-level control or continuous dimming. So what does that look like? Here you have a couple of windows, you have some partitions. If these partitions are 5 foot or higher, that stops the light effectively for purposes of the standard, so you only have to control the light out to that area. This limit here is the window head height, in other words, the height of the window from the floor. That's this dimension. And it's essentially 2 feet on either side of the window, and if the space between windows is less than 4 feet, this is considered one contiguous space. If it's more than 4 feet, you have 2 daylit spaces. Fairly straightforward. It's one window head height. One window head height. Now, that part there, one window head height, illustrates, I think for most people, certainly myself, how conservative this is. Same with the 4,000 square feet. We could be a lot tougher, a lot tighter. It would be more expensive. But there was a lot of analysis that went into this to determine that for every place in the country, and there are a few exceptions for other climates, for basically every place in the country, this will be cost effective. This could, of course, be more aggressive, and hopefully in the future there will be something more aggressive. But for now, this was a line in the sand, at least a start, to get daylighting control into the standard. The last part that Mark mentioned, this will be in Section 5. There is a requirement that if you have a large enough space, you have to put skylights in that space. And once you put those in, of course, then Section 9, the control, will come into play. So it'll work together. And in this case, it is in the envelope section. It does retain the 5% maximum skylight to roof ratio. You're not going to be required to put in more skylights than makes sense. And it only applies to very large spaces, greater than 10,000 square feet, ceilings higher than 15. And the requirement is that that daylight area under skylights, we just looked at that definition, must be at least 50% of that space. That allows you to exempt some spaces where perhaps daylight is just not an appropriate activity or not an appropriate application. You can apply 2 different ways. The total area of the skylights has to be at least 3% of the daylight area with a VLT, visual light transmittance, of at least 0.4, or a calculated skylight effective aperture that's at least 1%. And again, there's another definition for skylight effective aperture, but I'm not going to go through all those boring details. You can always get details from me later on if you like. Plug load or receptacle load control, I mentioned before. There's what we call a 50% requirement. It simply says you have to control at least 50% of your receptacles in an enclosed space, including those installed in partitions, with an automatic control device. And this can be, the automatic control device can be 3 basic types, either a scheduled basis, occupant sensor, or some other signal. How you pick the 50% is left up to the designer. That gives a lot of flexibility. You can put them all over in one place. You could put them half and half, a top and a lower one. That's left up to the designer. There are some exceptions, some places where it just doesn't make sense or might be dangerous to have a controlled receptacle, and those are listed as exceptions. The other plug load receptacle proposal that was considered was a way that limits how much load you can have in a receptacle, and at least the subcommittee decided for now that was just not practical and would never fly through the process. So, oops, sorry about that. Okay, updating the LPD values. This is something that's been worked on probably for the last 2, maybe 3 years, ever since 2004 essentially. We've gone through the entire set of models. We've looked at the way the models are developed. We've looked at ways of addressing some of the issues that have been brought up about the models. We've looked at all of the efficacies of all of the equipment and revised those because the technology has changed. We have looked at the choice of luminaires for each of the models because lighting power densities are based on models, made sure they're correct. A big change is to look at the room cavity ratio or room geometry. The geometry of the room, the length, width, ceiling height, etc., along with the reflectances, has a huge part to do with how much light power you need to provide the light illuminance in that space. And this was crude before, and we have fixed that. And I have a slide, I'll talk about that a little bit more. We also looked at those room cavity ratios because, quite frankly, when they were assigned for the 1999 standard, some of that was a bit arbitrary. And yes, to be honest, it was a group of designers and other practitioners sitting in a room based on their experience saying, yeah, that space is an RCR category of X. And we didn't always get it right. So we've done a much better job with actual real data of space type geometries and RCRs to assign that much better. We've also looked at obstructions and spaces that have odd RCRs, and those won't follow the same format as all the other spaces, so they need an additional allowance, and so that's been incorporated as well. Wanted to talk a little bit about the RCR category. The colored, the shaded items there, categories 1, 5, and 7, those are the only 3 choices you had before, and there's a huge gap between 1 and 5, and there's some stuff above 7, and so there's a lot of things between 1 and 5, and 1 got chosen, and some people would lose and some people would win. So what we've gone to is a 5 category approach, 2, 4, 6, 8, 10. That's maybe not perfect. We looked at 1 through 10 and realized that because of all the other variables, that just didn't make any sense to go that fine. So we're doing them on a 2, 4, 6, 8, 10 basis, which means we're getting a better accurate feel for what's actually going on in each space type. So the numbers are getting better to what they really should be. The reality is that when you do space by space, you pull the power of, say, this space into the power of the hallway and the restroom and everything else. So there's a little bit of flexibility there. But at this point, we've got them closer, so the flexibility isn't as much of an issue. You can actually do a better job of it. Here's a summary of what the current numbers look like. This is in draft. It's going to go out for public review very, very soon. Of the models that are in the table, printed in the table, 62% of them will go down because of efficiency and RCR effects. 9 of them will stay approximately the same, and about 16%, or 16 of them will go up, which we get a lot of pushback on, saying, why should a number ever go up? Well, the reality, again, just to be honest, is that we didn't have all the models right. We took the time and had the data to actually correct things that we found wrong with the models. And what happens is 16 of those models go up from small to large amounts. That's just reality. We had feedback from members of the subcommittee who said, finally they would admit, although they would complain about the ones that were too tight, they finally would admit, well, there's this group over here that have lots of extra wattage, and that's what we've been using to pay for the ones that are too tight. So essentially what we've done is fixed all of those. They're now not too tight or too loose. They're all where we think they're appropriate, and that's what's happened there. In the whole building numbers, most of those went down. One of them went up by 10%. Overall, when we look at some CBEX national weighted data, we think the whole building, not just lighting, but the whole building energy reduction will be about 5%. Help get us part of the way to that 30%. Other new requirements, summary and review. We do have a functional testing. You'll realize it as a commissioning requirement. That's out for public review. We are looking at revising the additional retail lighting power allowances. These are, you get extra wattage for retail applications, and we're looking at lowering those based on newer technology. We've got a monitoring proposal that says you have to monitor certain end uses within the building and provide that information to the building owner. We talked about the hotel bathroom control. Manual on, there's also going to be a requirement that whenever you put in an occupancy sensor, instead of it being fully auto on, you have to physically turn it on in most spaces, because there's an issue with things being turned on inadvertently, people walking by the room, or if you just step in to drop something off, you don't need to turn it on, which will garner some additional savings. So that's it for me, and on to progress indicators.
Thank you, Eric. We're now going to show you some of the material that we've been providing to ASHRAE in terms of what we call a progress indicator. This is basically tracking progress towards that goal of 30%. How well is ASHRAE doing? And we're going to talk a little about how we're doing it. And I'm going to go pretty fast through some of these slides. This presentation is going to be posted on our website. You'll be able to look at all the slides at your leisure. You're not going to be able to look at them at your leisure during the next 10 minutes because I've got to get done so Linda and Rose can talk. So what we're trying to do is measure that improvement, that 30%. We're looking at all the addenda that have been processed. We've got 10 building prototypes we're using, 17 climate zones. We've got weighting factors now that we use for all of this. This is all preliminary results. This has all been shown to the 90.1 committee, and we figured you might want to see some of it as well. It's a list of the prototype buildings we're using. There's incredible amounts of documentation on these. These are what are called the DOE benchmark buildings. There's an entire website out on the DOE website devoted to these. I'm not going to talk too much about them. Just keep in mind we've got 10 of these done, the ones in green. We're working on the others. We're going to have some more that we're going to start using in the progress indicator hopefully this fall. These are the weights. You probably can't read any of those weights. What this tells you is how much construction is going on by climate zone and building type in the United States. Where is the construction going on? Some climate zones are pretty important. Other climate zones are pretty unimportant. Be very interesting. I'm not going to spend too much time on it, but this is the result of some data we bought from FW Dodge. You got about 2 seconds, Mike. What is it? No. Here's some pictures of the prototypes we're working with. Here's what the kind of savings we're seeing in these new construction prototypes. Large offices, anywhere from 5% to 11%, depending on climate zone. Weighted out about 10%. This is current with the addenda that were approved up until probably the spring. So ASHRAE's still got some ways to go. Medium office, roughly the same, peaking out at about 13%. Small offices, again, these all look very similar to each other, up to 15% in the very cold regions. MidRise Apartments. We haven't had a model for MidRise Apartments for a long time, and we've got one now. The savings are a little less in the apartments than they are in the office buildings. Does go up to 13% in some climate zones. Typically, it's a lot lower than that. Warehouses, savings aren't as big in warehouses. It's tougher to do things in warehouses. You don't have as many levers to push in a warehouse. There's just not as much going on. Hospitals, very complicated buildings. Savings are low. Part of that is driven by the fact that the ventilation requirements in hospitals are pretty high, and that tends to outweigh anything you do to the building envelope, to the lighting. Primary schools, pretty good savings in primary schools, even better savings in secondary schools. Like I said, you're going to have copies of all this if you want off the website. You can look at these numbers in more detail. Standalone retail's got some pretty good savings as well. Strip malls, you can see the summary numbers. So ASHRAE isn't there yet. They're not at 30%. They're still working on some major things. Question in the back. I don't know. Not my decision. Are we going to post PowerPoints or PDFs? I'll ask Rose maybe.
I think it's usually PDFs, but if they want PowerPoints, they can let us know.
The answer was we usually post PDFs, but we could probably make the PowerPoints available. You can always send an email to Rose Marie Bartlett or to Mark Halverson, and we'll negotiate with you. All right. That was another question back there. Is that live?
Starting from the back, when we target this 30%, I saw in all your slides, I was looking at our zone 1, it was an average of 7% in comparison to the 18% on the far right. So what I'm trying to get at is we are targeting 30% savings, but according to your slides, the savings are always going to be more complicated on the far left of the climate zones. So how is there any alternate approach in order for us to also achieve a 30% savings, or?
You're talking about in the warm climates. What do you do in the warm climates? Yeah. There isn't an alternative code at the moment.
No, I understand all that. What I'm saying is that you're calculating savings using the alternate codes and all that, but still the percentages are way lower than 30%. This is based on what's been approved in the code so far. Okay. Going back to the external lighting zones, on the internal lighting zones, there is a provision for safety purposes, where you address like parking lots, where low lighting levels could be a safety issue. Therefore, you would need a higher light level. Or that's an Eric question, thankfully. Yeah.
All of the LPD requirements, interior, exterior, are all based on IES light level requirements. Mm-hmm. And there is a G1 security light level document, which in some cases a building owner will realize they're in that capacity, although it rarely happens. In that case, if there is a security requirement, that would overshadow the energy requirements. But generally, for most applications, they're based on IES requirements, and that's the standard of care for the industry. So those are incorporated. And second question for you is, when you're using side lighting for daylighting purposes, you had, for the top lit, you had obstructions calculations for stuff, for light calculations. If you have side lighting, would you have the same provisions for light shelves? No, there isn't anything at this point for light shelves. That's another complexity level above what we have here now, and we're hoping in the future we can incorporate that. But for now, this was our line in the sand, our first initial step. So there's nothing about light shelves in the current proposal, no. Okay, thank you.
Okay, we're going to move on and talk about training for a couple of minutes. It's always exciting to be after lunch and to be after Dave Conover, Mark Halverson, and Eric Richman. And so they put Linda Connell and I at the tail end to make up time. So, well, we're not doing too bad. You guys did good. My goal in my very short presentation on training is to have all of you realize that we, the Building Energy Codes program, have a lot of training materials available from our website that I have up here, energycodes.gov. And the takeaway for my part of the presentation is all of these materials are available to you. Please steal them, modify them for your own use. I get several questions a year asking if people can use our materials, and that's why they're out there. So please take them, modify them. One of the goals for the training part of the Building Energy Codes program is to put basic presentations out there that cover things like the basic code requirements that you then can take and modify as you like. So please steal our stuff. So that's my message. You steal our stuff from the website. I'm focusing on the training and education section of the website. There's a very brief overview of the materials available to you. One of the most often used parts of the website and in this section are our recorded webcasts. In the last 3 or 4 years or so, we have focused heavily on webcasts as a training delivery mechanism, and it's been very successful for us. We average anywhere from 7 to 10 webcasts a year, and we're averaging about 1,500 attendees per webcast. We make these webcasts available to you through the recorded webcast link. We have self-paced materials as well as the presentations that you can steal. We also have an events calendar. If any of you are hosting any training events or any other energy code related events, you actually can go to this part of the website and post those yourself. There's an energy codes glossary. When I got up here this morning, I mentioned the comments that had come in about acronyms. So we have a lot of those acronyms explained in that part of the website. And then lastly, this is the section where you get more information about this annual event. I was asked to talk just briefly about the materials that we currently have available for the 2009 IECC and 90.1 2007, since those are the ones we're interested in at this moment due to the Recovery Act. For the 2009 IECC, we have PowerPoint presentations available. So we already have out on the website a presentation for the residential requirements of the 2009 and commercial requirements of the 2009. So they are already available. In June, we did a webcast on the residential requirements. We had a little over 1,800 people attend that. That video is available out on the website. We also have available some new code notes. The code notes are put together for items in the code that might be a question, typically for code officials. So we give some further explanation about the code requirement to try to help explain the requirement, but also so when it's inspected and so forth, the code official knows what's acceptable or not. On the table out front, there were some, and still are, some folders, BECP folders. Those were not in your registration materials, so if you haven't had a chance to grab one of those folders yet, you might want to. In that folder is our cool BECP bumper sticker and some other materials about the program, including 2 of our very recent code notes. They both happen to deal with lighting, related both to the 2009 IECC and 90.1 2007. We currently have in the works 2 code notes for the 2009 IECC related to the duct testing requirements. So if you've had questions about those, stay tuned. Those will be available soon. Also coming soon, probably late August and early September, we're going to have a 3-part webcast on the commercial requirements of the 2009 IECC. When I get back to the office next week, I'll be getting those dates set up, so everyone will be getting a blast email on those. Our self-paced tools, which are tools available on the website, take you about a half hour to an hour to go through if you just have a spare time to sit and go through the materials. You can learn more about ResCheck and ComCheck, and Linda's going to talk about that here in just a minute. We will be updating ResCheck 101 and ComCheck 101 for the 2009 IECC. Those will be available on the website by the end of September. Related to 90.1 2007, we have several PowerPoint presentations already available. They are playing now. And we have a recorded 3-part webcast series that's also available on that recorded webcasts page on the website. So please, again, take our materials, steal them, modify it, and use them. And if you have any comments or questions about anything that's out on the website, feel free to let me know. Linda?
I'm going to catch us up a little bit more by skipping my slides and I found a mistake in them anyway this morning, so this works well for me. I do want to tell you, though, that there are 3 Cracker Barrel sessions this afternoon, all on our tools. One of them will be given by Pam Cole, and she's going to go over ComCheck and ResCheck and what's new in them, including the 2007, 90.1 2007 is already in those tools. And we do have plans to have IECC Chapter 5 in ComCheck by the end of the fiscal year, and we are close to being ready to release 2009 ResCheck, the IECC 2009 in ResCheck. And so I'm also going to commit a mortal sin here by showing some beta software. It always crashes when you're showing it to external folks.
And good luck with that.
Yeah. Okay, I won't. All right, so what I wanted to show you is the 2009 IECC has something very different in it, and that is they've removed the mechanical trade-off credits in the code. And a lot of the frequent ResCheck users are very used to using that trade-off, and it's an important trade-off to a lot of those users. So we were very careful in how we supported or did not support the mechanical trade-off in our software to make it obvious to our users. We kind of see the codes kind of going into very prescriptive approaches and then also full building simulation and performance-based approaches. And so in this version, we are supporting both. And when you come in and select the 2009, I'm going to open an example file here just to use. Looks like I already had it open. I'll reopen it. To take you through this. By default, you're going to end up in a UA calculation approach. If you're familiar with our 2006 version, we kind of hid the fact that it went between UA and performance. We do have DO2 behind the hood here, and if you selected mechanical equipment in the 2006 and you didn't pass by UA, it would automatically sort of behind the scenes take you to the performance approach. It's a very limited performance approach. But we didn't tell you. We're getting away from that in this version. The user needs to come in and specify which approach. We're actually working with Energy Plus in the back end of some of our other tools, and we think this will help to prepare our users for understanding the difference between these approaches. So in the UA approach, you can see that this building passes by 0.5. If I switch to mechanical, as our users are used to, you're going to get a note that says there is no credit anymore for HVAC equipment in this approach, and it's going to tell you if you want to try a performance approach to go up to the options menu and change it. Now the thing is there is no trade-off on the performance approach either in the new code. What the code says is that the equipment, the proposed equipment, is the same that's going to be used in the code building when you're doing a comparison. So it can have some impact, by the way, in a performance approach. If I choose high efficiency equipment, it can give me a little different results. It's going to assume that high efficiency equipment in both the proposed and code building when it does the comparison. So anyway, under options, I can come to a compliance method and I can choose the performance approach, and then I get some kind of lengthy explanation about that. And at this point, I have to actually manually ask for my compliance each time. And there's not weather data on this computer, and there's probably not an internet connection. I knew the beta wasn't good to run. I think Denver, Colorado, I think the install comes with weather data. So let me see if that will work real quick. Is that true, you EP, your DO2 users? We'll see. Nope. Okay, well, what I would have shown you, first of all, this won't run. It won't run without the weather data, and you do need an internet connection. But it also won't run without the orientation mode selected. And what we'll try to do is get this ready for the Cracker Barrel for you tonight. But this building will now fail, the one that just failed by 0.5. It will fail with this side facing the front. You are able to rotate your building through various orientations, and you will find when one of these 4 cardinal orientations will pass by a little bit more than the UA approach. The other thing to know is that the SHGC is rolled into the performance approach. So if you're using UA, it's just you have to have an area weighted average that meets that minimum requirement. In terms of the performance approach, the SHGC is part of that approach. Yes?
Is the user told right up front that there's no mechanical trade-off?
Yeah, if you are, first of all, if you are, pardon?
That's all I need to know.
Yes.
They're hammered with it, right, as soon as they open up.
I wouldn't say it's as soon as they open up. As soon as they go to that tab. So as soon as they try to enter anything, they get told right there. So, yes. Okay, let me just say one more thing. The other Cracker Barrels, Pam Cole's going to be showing our tools. Bob Weibel is going to be doing a Cracker Barrel on interoperability between regulatory software processes and our tools. And I will be doing a Cracker Barrel that includes not only the other interoperability aspects that we have, we've got some XML and data exchange formats, but also our linking of Energy Plus to the back end of our tools, including the ability to export from ComCheck into an Energy Plus file and view it in SketchUp. So I'll be demonstrating that. So yes, we can take any questions for other folks. Go ahead.
No, yeah, sure not.
Touch briefly on like the ASHRAE versus the IECC, and just kind of reiterate, if we can get a determination on that sooner rather than later, because I know that there are states that are certainly talking about adopting the IECC 2009 versus ASHRAE to comply with the Recovery Act. But also I wanted to ask, has DOE completed the IRC versus the IECC energy code portion in terms of whether that's going to be eligible for Recovery Act funds? And then also, is there going to be perhaps a guidance that's going to come out whether or not that's going to be valuable about the same time? Because again, that's something that states are dealing with now.
Gene, would you like to step to a microphone?
I'm sorry, this microphone doesn't seem to be operating over here. That's going over. I turn it on. I didn't get the question.
Come on up and join us on the podium if you want, Gene. Gene will be answering that question.
You need to repeat it, Mark.
While I come up, would you repeat it for me?
Yeah, if you could repeat it once Gene gets up here.
Okay. One, just a statement that getting that determination on whether ASHRAE versus IECC is going to be okay for states is something that we need sooner rather than later. And when do you expect to possibly have that laid out for us, because states are making those decisions now? And the same on, is IRC versus IECC, the energy portions, being decided yet? And are you going to have a determination on whether that's going to be okay for the Stimulus Act funds for state to adopt? Because that's also a big question that we're having in areas as well.
Yeah, I don't think we are going to make a formal determination as to whether the IECC and 90.1 are equivalent. It will be dependent upon various areas of the country. We are totally stressed out at department to be able to make those formal decisions. You've seen the technical work here, but someone making that decision formally as a part of a determination that will affect the secretaries making explicit decisions probably will not be made. It's going to take an awful long time to do that. This information will be made available to you. Mark's presentation will be on the web, and we will answer some questions from that. If you have explicit questions, we'll do that. As far as the IECC and the IRC, I have had a paper ready to send out to people, but we have been totally subsumed by this exercise that Scott explained yesterday, that literally he has been scooped up in to look at all of these proposals. I promise I will get it out just as soon as possible. It will not be a formal answer to your question, but it will explain where the differences are and what they are so that states can make an informed decision. In that area, the prime states involved are in the southern tier of the country. We would like to very much do that for you, but our circumstances just haven't permitted it.
So is there a possibility then that states that adopt IECC 2009 versus ASHRAE could still be eligible, that we can still go forth and tell governors you don't have to be as concerned about adopting IECC over ASHRAE?
I think they'll have to take a look at the information that we produce and make those decisions on their own. On their own. I'd like to give you a much better answer than that, but that's where we are.
While you're standing, I have a follow-up for you,
Okay.
and then a question to Linda. The 1992 Energy Policy Act required states, once there was a formal, positive determination made by DOE, actually required the states to adopt 90.1. It's a straight requirement in there. And for many years, states have adopted the IECC for both residential and commercial and haven't specifically adopted 90.1. And as far as I understand, DOE has never challenged those states that have adopted IECC commercial. They've just kind of, I think, let it go. If you're not planning on making a formal determination and you're turning that back on the states, is there any indication from DOE whether DOE or someone is going to challenge those states that are adopting the IECC for residential and commercial?
Let me take half a step back. The requirement that you're talking about is almost that what you say, but it's not quite that. It's to adopt something that meets or exceeds ASHRAE Standard 90.1. I just wanted to make that clear for other people who may not know that. The situation about a number of states adopting the IECC in lieu of ASHRAE Standard 90.1, the equivalency has been so narrow recently that there hasn't been a problem with states doing that. And we weren't going to expend the effort to make a hairbreadth decision. Those are things that the states can do. I really don't have. I've asked, and I haven't gotten an answer myself about the formal decisions as to what DOE is going to do. It would be very nice if we had the time. Under normal circumstances, we would be have planned and budgeted and made some very rational decisions as to how we were going to handle this. All of this money has come to us within a matter of the past 6 to 9 months, 6 months, and we are running just as fast as we can to handle it. I'd love to give you a coherent answer on that. I really can't.
But this is
will
good.
The concern is understood back there.
Right. I mean, you've obviously done a lot of work in this direction and very quality, research into this. And I doubt any state on its own could take that type of a look or that detailed a look at both codes. And so, I'd encourage DOE to make that one final step and make that determination, because I doubt there's any state that could get to that granular level to analyze the two codes.
I think you can take a look at this data, see where the savings are in your region of the country, and make some of those decisions. The formal process of doing so within the department is going to be a very long one.
Okay.
I hear your pain and your message, and I sympathize.
Okay, we have time for one more brief question and answer.
Be brief. This is just to, and Gene, actually, this might apply to you.
A little closer to the mic.
This might apply to you all. So this is just a source of confusion for me. in this whole question about adopting the IECC and ASHRAE 90.1 2007, under the understanding that if a state adopts IECC 2009 for both residential and commercial, because there is a reference in IECC to ASHRAE 90.1 2007, doesn't by definition a state that adopts IECC adopt something that meets or exceeds ASHRAE 90.1 2007 and then can go its merry way?
Let me give you an example on that. If I can go out and comply with the lighting requirements for this room under ASHRAE standard, which would be by reference, I might be able to go out and not comply with the lighting standard if I use the IECC for a particular building or a particular space. Our judgment on whether those are equivalent would be based upon the least stringent of those requirements. So therefore, just because the standard may reference either this track, ASHRAE standard 90.1, or the internal track, the IECC, doesn't make them equivalent. I might be able to go one way and it may be more stringent, or it may be less stringent, and that would be the governing factor.
Thank you very much. Can we have a round of applause for our panel?